Good morning, everyone. Welcome to the technical session 4. It would be graphics and visualization 2. My name is José Gustavo Paiva, and I'm from Universidade Federal de Uberlândia. We have 6 interesting works that will be presented here in this session, and I would like to thank all the authors here today. These works cover several topics, including literature exploration using text and image content, visual analysis of clinical trial monitoring, analysis and creation of personalized materials, magnification of subtle motions and color variations, as well as dimensionality reduction works focused in the cluster formation analysis and also focused in data stream scenarios. I also thank all the attendees here. I really think it will be a very good session. We'll follow the same workflow of the other sessions. We watch a video with no more than 5 minutes about each work. During the video execution, all the attendees can post questions to the authors on YouTube comments and or in the Discord chat. We'll collect these questions and discuss them with the authors after the video. We'll have about 6-7 minutes for questions after each video, and I really ask you to please post the questions as soon as possible on the YouTube chat because we have a delay on the YouTube broadcast. After the session, you can continue the conversation with the authors on this session Discord channel. Okay, so let's start the presentation. The first work is Drift, a visual analytic tool for scientific literature exploration based on textual and image content. The authors are Jimena Poco and Eric Gomes Nieto from Universidade Católica São Paulo, Jorge Poco from Getúlio Vargas Foundation, Matheus Viana and Rogério de Paula from IBM Research, and Luiz Gustavo Nonato from ICMC, University of São Paulo. You can start the video, please.
Exploring digital libraries of scientific articles is an essential task to the research community, in both academia and industry. Traditional mechanisms display stored information without almost visual resources. They present briefly textual information by article, in a list-based layout that does not allow exploratory operations. If instead of having an article as a reference, the user has an image, the process of finding and explore articles with similar content becomes almost impossible. We propose a 2-step method for exploring and analyze scientific document collections by combining image and textual information extracted from articles. Multi-CBIR view allows us to input up to 5 images and then obtain a similarity-based ordered list of images by each query. The similarity can be defined from a distance measure between feature vectors. Each query is represented by a different color in the multidimensional projection view. This component maps all the papers of the dataset. Textual information from each document gives rise to a high-dimensional vector that represents the document. Control points are mapped with its respective color of query, and green points correspond to the rest of papers. Linked items. Through hovering over an image or point, Drift will highlight a document and its contained images displayed among components. List-based selection refinement view shows the list of selected documents, depicting the title and DOI. Selection content summarization view. Drift shows a histogram with the most cited authors, a word cloud with information of paper's content, and its year publication histogram. Selection inspector view represents selections made by the analyst. Each selection is composed of the number of images, documents, and others. They are displayed with their respective color of layers. User interaction with control points. The analyst can move the control points based on the analysis obtained with the other components. Then, make a selection and add it to the Selection Visual Manager. Choosing A and B states makes it possible to compare them for filtering. State Manager view. This view displays titles, authors, and images. Besides, it adds the option to select the most important documents for the analyst. Finally, a more filtered state containing pertinent items could be generated.
Okay, thank you. I would like to thank the others again. We don't have any question here, so I'll start with the first one. Have you thought about linking figures to their captions or to the text around their references in the paper in order to enhance the search by adding annotation to these images? Because you're using picture vectors from the images to compose the control points, right? So have you thought considering using also captions from these figures, like just to annotate the images and enhance this search?
Captions of the images.
Yeah.
We doesn't consider before, but I think it's a good idea to add for the next version. Even though the link that we showed on Drift is related in between the component of CBIR and the mapping of the projection. So the link is visual. It's graphically visual in order to when the mouse is hovering over the points and when the mouse is hovering over the images of the CBIR too.
Okay, because what I think it would be good, considering all this extra information, would be to better contextualize the image in the paper. I mean, for the search, because maybe the image the image itself doesn't represent much what you were trying to query in your search. So maybe that could be an enhancement that could better contextualize the image. The things.
That's right.
We have a question here from Discord. I don't know who posted the question, but is it possible to use Drift to search papers that do not have representative images, such as language processing? I mean, you don't have much images in the paper related.
That's a good question. In fact, that's one of the limitations of Drift. We thought this idea for the people who didn't know the right words to start their search. So they have images. So if they have images, they can start the exploration and get some knowledge to find the keywords for their search and key papers. In the field of language processing, this field doesn't have representative images, so that's a limitation of Drift. But Drift can be, for the next versions, we thought can be added a function to make search by text, and that can be include this kind of papers, this kind of research. So just they don't have images, but they can be searched by text.
Yeah, it leads me to my next question. That would be, for example, you use the control points are guided by the image, right?
Yes, the control points are the papers of the images returned by the CBIR.
Yeah, but for example, you could, instead of using a CBR to make the control points, you could use, for example, a textual search. Right. So of course, you could end up in a situation that you don't need the images anymore, but you could, for example, combine images plus text to guide this projection. Does that make sense?
And for now we have this combination of images and text.
Okay.
But only use text can be just for the kind of for the papers or for the research fields that doesn't have so much images, but it's not implemented in Drift.
Okay. We have another question from Victor Flores. From your article, I understand that you use PCA. Did you test any other dimensionality reduction techniques such as TSNE?
We use
Actually, I don't think it's PCA, right?
yeah. For the dimensionality reduction, we use I remember that we use TS4, but yeah, we use it.
I think you use LAMP, right? On Drift. Is that correct?
That's right. Yes. For mapping, we use LAMP, but in order to map the points, that's related only for the text of the papers.
Okay. One more question is, for example, have you had another study case? Have you experimented using the drift in another real scenario other than I think you used? I don't remember. I read it on the paper, but I don't remember exactly the use case that you used. But have you thought about using it in another kind of scenario? Have you already made an experiment in another scenario?
We define 3 data sets, all they related with papers of what? The first was related with topics of astronomy, disease, market. The second, I remember and the third, those related to topics of computer science. Well, we define 2 case studies, and finally a user study with 6 researchers of computer science, and that's the most realistic scenario. Even in this pandemic situation, we try to make the using the technology, people interactive with our tool, and we obtain feedback of Drip. So that's most realistic scenario we try to create for this experiment.
Oh, great. Okay, I think we don't have any more questions. Okay, then thank you again, all the authors. Thank you, Jimena, for your presentation. And I think we can move on to the next paper. Now, of course, I would like to reinforce that you can continue the discussion on the Discord channel with the authors. Okay. Okay. So our next work is interactive visualizations to support randomized clinical trial monitoring from Marina Flores Rey e Carla Maria das Sás Freitas from Universidade Federal do Rio Grande do Sul. You can start the video, please.
My name is Carla Freitas, and I'll present a work entitled Interactive Visualizations to Support Randomized Clinical Trial Monitoring. Marina Rey and myself developed a visualization-based interface to support the monitoring of Linda Brazil, a long-term clinical trial conducted by epidemiologists at the Federal University of Rio Grande do Sul. Linda Brazil is focused on a lifestyle intervention program for women who had gestational diabetes. The intervention aims at preventing type 2 diabetes and is based on regular phone calls when coaches encourage women to improve several aspects of lifestyle. Linda Brazil is a multicentric study and follows a sequence of phases. First, women that are diagnosed with gestational diabetes are recruited into the study. They are followed up coaches with regular phone calls. If a woman is eligible to participate in the trial, she is invited to a clinical visit for baseline testing and is randomized into intervention and control group. The study proceeds with phone calls and yearly visits until the last one is scheduled for 5 years after the randomization date. At the end of the study, the main outcome observed is whether or not the participant developed diabetes. There are several secondary outcomes which mainly assess whether the participant was able to apply the changes proposed by the study in her lifestyle. Related work can be divided into 4 categories: systems that display patient data as a time series with a common time axis, systems that are based on dashboards, those that show similarities between patients, finally, systems that allows comparing and analyzing cohorts of patients. We analyzed related works based on characteristics we found in a survey by Ryan and co-authors. We can observe that most systems display categorical data, while some do not include numerical data. While most of survey tools separate views of single or multiple patients, our work presents a hybrid approach, allowing users to interact with the cohort of participants while viewing specific information from each subject of the study. Most tools are limited to presenting a few data on a single view, while our work can show an overview of around 90 different variables. After a year of meetings and interaction with experts, presenting and evaluating prototypes, we were able to provide a visualization-based interface for the Linda Brazil clinical trial, where high-level tasks are supported by interactive visualizations. The final version was evaluated by 3 experts and 16 non-experts. From these high-level tasks, we derived requirements, which led to more specific tasks. Then, we designed 4 main visualizations to support them. In the participant's dashboard, the coach has all the information about the participant, including the questionnaire completion status. The chart in the center of the dashboard shows the participant's weight over the years and the important events like the dates of childbirth and randomization. By selecting the Variables tab on the right, the coach can access charts displaying all the data collected for that participant over all phase she has already went through. This temporal data is shown in specific charts depending on the category. Some variables are actually groups of subvariables, which are shown in a single chart. Using the Variable Selection view, the user can observe the distribution of variables and discover incorrect or missing data. The main goal of this view is to allow the selection of variables and phases of the study used to obtain a scatter plot from a dimensionality reduction technique. In the Participants Information Analysis view, the scatter plot shows the result of the selected dimensionality reduction technique, which allows observing similar participants and explore their progression over the years. Finally, the Questionnaire Status view allows assessing the completion of each phase for each enrolled participant. In summary, our contribution is a visualization-based interface that provides an integrated and detailed overview of all data collected from any participant that allows coaches to assess the effectiveness of the intervention, a visualization of the current status related to all study phases for each enrolled participant that allows to assess the progress of any participant or group of participants, a histogram matrix showing the distributions of all variables for any phase of the study that serves as filter or parameter selection for further analysis, and a scatter plot-based visualization that allows investigating similarities between women, which is particularly important to prevent participants from leaving the study. As future work, we would like to include visualizations to compare multiple cohorts of participants, to include the statistics for subsets of participants, and to deal with data from different clinical trials. Thanks for your attention.
Okay, thank you again for the author. Let's see, we don't have questions yet, but I'll start then. First of all, I liked very much your system design and all the visual choices that you've made on the work. That was a very good job. Thank you. I would like to ask you, Carla, can you tell us more about the challenges when assessing the experts that deal with Linda? I mean, because you had a problem, and then you collect all the feedbacks. I believe from the experts that deal with Linda daily. Can you talk a little bit about the challenges when doing that?
Yes, trying to work with users from a different domain is hard. But actually, we started to talk with this group like I think 3 years ago, because they run 2 different clinical studies. They run a project named ELSA, which is a long-term project. It's like, I think, almost 6-7 years. And Linda, which is a second study. So we were used to talk to them and to learn how they want things done. But it's a challenge because we, as you could see, we have a long prototype, and we went to for example, we went to employ much the scatter plot, with the dimensionality reduction technique, but they just one of them knew that, so it's abstract, too much abstract for me. And for the participant dashboard, they wanted only the weight, because that was the main variable they track along the phone calls. So trying to get more data into the interface was a challenge. But I mean, in the last phase, we had a very good evaluation, so we are really proud about the results.
Yeah, because exactly as an interdisciplinary work, I imagine, as you explained, did any of them have any idea about what is a visualization system, or are they expecting, for example, a conventional system with buttons and tables as results, or at most some line or bar chart with some summary results? When they saw the visualization, a more sophisticated layout, did they have any shock reaction?
No, not actually, because we went very slowly. At first, they wanted, because when the coaches have to do the phone calls, they like list, they have a report, like a dossier. So they at first they wanted that dossier, so we gave them the patient dashboard, and then we follow like the other views. So it was like more than a year of meetings, like in a regular basis. So they were slowly introduced to more sophisticated visualization. That's why I think we got a very good evaluation in the end.
Oh, that's great. We have some questions here from Luis Henrique de Figueiredo. Do you have visual designers in your team?
No, actually, Marina did it all. So she was our designer. Actually, she is a very bright, developer, and did all the programming. And she actually designed all the icons and all the all the. Of course, we discussed it, but the choices that she made in the icons and in the charts, it was her. So she's very bright. So actually, this work is her master dissertation. So so that's why it is rather complete.
Great. From Alexandre Ramos, congrats and thanks you. That's a great job. Could you comment on the language and technologies used during the development?
Yes. So the front end was built on Angular, Bootstrap, and D3. And she used some libraries for dimensionality reduction and icon pickers, I guess, and some other codes. But she did all in D3 for the visualization part. And the backend is a Postgres database. So she used a PHP to get the queries, and that was hard because there are hundreds of questionnaires. So she had to at first users had to wait like half a minute to to get all the data. So she designed, she came up with a solution to get a materialized view from the database, and then things went in real time actually.
Oh, great.
And then you can since working with a materialized view would maybe data would be outdated.
Okay.
So we have a button to update the data if you want to get the real data that is in the database.
Great.
So mainly, for the visual part, Angular, Bootstrap, and D3.
And D3, yeah. I think we have time for one last question, so I'll make it. Also related to the user experience, did they related any interesting fact that the visualization revealed to them in terms of, oh, I didn't know it was happening, something like that?
I can't recall any precise example,
Exactly.
but every time we had the meetings, they usually saw a chart, for example, and now that that chart shows that the participant is almost leaving the study, and we had also filters, so you can filter, for example, how many women didn't haven't come to the last visit that they should have. So they every time they discovered something new in the interface. So that was also interesting.
Due to the time, I think we have one last question.
Yeah.
Can you just a quick one? So, in your paper, you presented a questionnaire status view. Did you use some kind of reordering to sort the participants from Silmar?
Oh, it's it's a basic order. The participants are ordered either in alphabetical order, or in the order the phase completion. So the participants that are, because participants are randomized in series. They are not they were not randomized in a single date, for example. So you have participants that are following the study. So the order is based on the how long they are in the study. So that's the first order. But those are the two only options that we have.
Okay. Okay, then thank you again, Carl. Thank you again, all the authors, for the good job. We'll continue the discussions on Discord. Now we move to the next paper, an appearance-driven space to create new BRDFs, from Ms. Lene da Silva Nunes, Gastão Florencio Miranda Jr., and Beatriz Trinchão Andrade from Federal University of Sergipe. You can start the video, please.
Hi, my name is Ms. Lene da Silva Nunes. I'm here to present the paper entitled An Appearance-Driven Space to Create New BRDFs. The co-authors of the work are Gastão Florencio Miranda Jr. and Beatriz Trinchão Andrade. We are from Universidade Federal de Sergipe, Brazil. The reproduction of reality in computer graphics requires comprising the behavior of materials when they interact with light. Reflectance functions are responsible for characterizing the material's appearance. They are often implemented as bidirectional reflectance distribution functions, BRDFs, that model the way a material reflects light. Our motivation is to increase the number and variety of materials based on real measurement without capturing new reflectance samples. These materials can help in artistic work and be used in many applications, such as entertainment industry and computer-aided design and manufacturing. However, a larger number of samples is required to reproduce the reality with fidelity. So, They are a field database composed of tabular BRDFs. Our goals are to provide a pipeline where the user can express the appearance of the desired materials in terms of already existing tables, to propose and brush to cluster materials from tabular BRDF database, to develop a personalized space according to the user's interests, and to create novel personalized materials. I will describe the pipeline developed to create new materials. First, materials from the tabular BRDF database are selected by the user based on renders of the materials. Then, based on the materials selected by the user, an appearance space is generated, and the navigation in appearance space is performed. So, points in that space are mapped to the tabular BRDF space, and the new materials are created. The Mitsubishi Electric Research Laboratories BRDF database was used as input. K-means and K-means were compared in the cluster of the Mitsubishi database. K-means, with 7 clusters, presented the best result and therefore was used in our pipeline. We computed the best parameter for 2-dimensional reduction methods according to the capacity to preserve the distance between image slices, multidimensional scaling, and isometric filter map. Isomaps stand out to generate materials that change smoothly during navigation between neighboring points. This resulted from our pipeline using isomap. In each row, the first column represents the first control point. In the last column represents the second control point. Material between these control points are new materials created. For more detail about this result, please refer to our work. Our approach creates new customized materials from tabular BRDF database, MDS, and isomap, where you compare the creation of an appearance space and isomap presented better results. Appearance space provides novel materials with visual richness and realism. Thanks so much for watching.
Okay, thank you, Ms. Lenny. Thank you for your presentation. Let's see if we have, we don't have questions yet, so I'll start with one. Users must select materials from a tabular BRDF, right? Have you made an experiment about the size of the materials, size of, I would say samples, he or she had to do on the tabular? I mean, does she have to choose a large number of materials, or does the technique handles well with a reduced set? Can you tell us about it?
So, let me see if I understood your question right. About the number of samples of materials, or a larger number of materials are requested?
No, the samples. The samples.
The samples.
Does the sample set has to be a large set, or yes, the technique is able to deal with a reduced one?
So, the materials table of BRDF, there are a larger number of samples. So this way we have used image slice to select the most important samples of the materials, because this way we can improve the use of a dimensional reduction method applied in this new database, because we have to pre-process the tabular BRDF database with image slice technique, and this way we have the most important samples of the materials, and the tools and dimensional reduction method applied these materials, we got a less processor consumption and this require the storage space. This way to improve the method applied in the way for example in execution of the method, because when you have a lot of samples, we need hard processors if we have some dimensional reduction method. So
Okay. We have a question from YouTube. Is it possible to export the generated BRDF model, either analytically or as a probability distribution? For example, if one wishes to apply that BRDF to an existing render, for example.
well, our approach can be applied any BRDF. This BRDF can be tabular or from reflectance model. Just needed to get the image slice from the material. So, for example, if we use the Explore BRDF Disney tool, we can get the image slice from reflectance model or BRDF or tabular BRDF. It's possible. Just need to get the image slice.
Okay. From Marcelo Walter, nice work. There are other BRDF databases. Could you use, for example, the Curate database from Columbia or Utrecht universities?
Yes, there are others BRDF database, but we chose the mirror BRDF database because there are a lot of work that you use in this database, and the way of the material are sampled is different from UTIA BRDF database and the mirror BRDF database. So it's necessary to our work to obtain the image slice from TLBRF database. We have to think about that, but we didn't have time enough to make this experiment to try another database because the sample is different from databases, right?
Different methods to
Yeah,
present the materials,
yeah,
right?
yes.
Okay.
Exactly.
And also from Marcelo, you mentioned that 7 clusters presented the best results. How did you check this?
So we use a silhouette index, right? And we have to compare how the most high value from the silhouette index, and we have to choose a linear from the Matsuki et al., which was 7 as minimum value number of clusters, and we make a lot of results from different number of clusters. That number provided us the high silhouette index more than 7 clusters. We have chosen to be using in our experiment. Furthermore, we showed the image slice clusters and groups. They are in our supplemental material.
Great. Okay. I don't think we have time for more questions. Thank you again, Ms. Laney, for the
Thank you so
presentation.
much.
And we can continue this discussion over Discord. Let's move on to the next work, simultaneous magnification of subtle motions and color variations in videos using RIES pyramids, from Thomas V. Fontanari and Manuel M. Oliveira from Universidade Federal do Rio Grande do Sul. You can start the video, please.
I'm going to present a work entitled Simultaneous Magnification of Subtle Motions and Color Variations in Videos Using RIES Pyramids. Subtle color and motion variations in videos are usually invisible to the naked eye. They nevertheless carry useful and important information. For instance, there are skin color variations resulting from the cardiac cycle. The chest and the head move when someone is breathing, and structures undergoing pressure can deform. Visualizing and extracting these signals has therefore multiple applications, from tools for medical diagnosis to applications in industrial equipment inspection. Because of this, several algorithms have been developed in order to amplify this type of signals. Important work has been done by Vu and his colleagues using only spatial and temporal filters. As an example, given this apparent static video of a man's face, they were able to reveal the skin color variations caused by the man's heartbeat. This method, however, could perform only limited and noisy motion magnification. For this reason, Vadva introduced a method based on the local phases in the frames of the videos. They were then able to reveal, for instance, that a seemingly static crane was actually moving because of the wind. Their technique increased the possible levels of motion magnification and reduced the noise introduced. It was, however, applicable only to motion. Other techniques were introduced later that aimed at fixing different problems with these previous techniques, but they didn't try to provide both high-quality motion and color magnification. Our technique fills this space by extending one of the motion magnification methods, such as to allow it to also amplify color. Hence, in this work, we demonstrate how the RIES pyramids and image representation previously applied only to phase-based motion magnification can also be used to magnify color variations. This allows us to develop a technique that can magnify both color and motion simultaneously. Finally, we also introduce a mask based on the chrominance values of the pixels, which allows only regions of interest to be magnified. Our technique for simultaneous magnification of motion and color variations works essentially in the following way. The algorithm takes as input a video and decomposes its frames in a pyramid representation containing measures of spatial, phase, amplitude, and a low frequencies residue. The phases, amplitudes, and residues then undergo a temporal filter which selects the signals of interest. These filtered signals are then used so that amplified versions of the phase, amplitude, and residue can be obtained. Finally, the frames are reconstructed using these amplified values, resulting in a video where only the signals of interest were magnified. We illustrate some of our results in the following video. We implemented an application that allows the use of our technique for simultaneous motion and color change magnification together with our chrominance-based mask. We first magnify motion and color variations at the babe's face. We can also select the babe's blanket. And we can increase the motion magnification levels and reduce the color change magnification level, since in this case, magnifying the color variations does not produce good results. Finally, we let only the color variations at the babe's face visible. A still relevant question is whether the magnified signals obtained using our technique correspond to signals that actually exist. To verify this, we analyzed the video of the babe, where it's known that the babe's heart rate is 151 beats per minute. We magnified the color variations at the baby's head, marked in green at the image, to obtain the follow magnified signal in orange. By selecting the highest magnitude of the frequency spectrum, we can obtain an estimate of the baby's heartbeat from the video. In this case, we obtain the value of 150 beats per minute, which is very close to the actual answer of 151. Thus, we presented a technique for simultaneous magnification of motion and color using his pyramids. It's possible to use it to magnify only color, only motion, or both signals together, and different temporal frequencies can be used for each signal. In addition, we introduced a mask based on the video's chrominance values, and that can be used in real time due to its simplicity.
Okay, thank you, Thomas. Thank you, every author, for all the authors, for the good job. I don't know if we have questions yet. We don't have, so I'll start with one. Do you believe your technique can be used for subtle but not that subtle variations in color and motion? For example, do you think it can be used in a surveillance scenario to capture some more subtle movements or abnormal movements on the scene? What do you think about it?
Yeah, it really depends on, as you mentioned, how subtle this motion is. If the person starts moving, for instance, really actually moving from one place to another, then there will be a lot of distortion in the resulting video. But if the person is trying to hide himself, then it is possible it would be useful. If I can elaborate a bit further, if there are not other questions, then this reminds me of a similar work that tried to check if someone was dead using using these techniques for motion magnification. So trying to check if his chest was moving. Mm-hmm. So this is similar to what you thought about, maybe. And in their case, they argued that it worked. So it's is possible as long as the person's not moving so much.
Yeah, because, for example, we have some problems in surveillance scenarios because usually the camera is fixed. So sometimes the object is very far from the camera. So the camera would tend to capture the movements, but they would be so subtle that usually the agents will not perceive that. So in this case, that I see there's a potential for your technique to be used, right?
In the way you describe it, it does sound like a good application for the technique, which had not occurred to us. It's a nice idea.
Yeah, I'm dealing with surveillance scenario, and that that problem has already merged in my research. That's why I'm saying that.
That's very interesting, very interesting. I didn't see, I don't remember seeing any work that was specifically about applying this to surveillance. So maybe it's an interesting area to try.
Okay. I visually notice that your approach performs better than an approach that makes motion and color sequentially, as you mentioned in the presentation. But I visually see it, but do you have any numerical experiment that confirms that?
Unfortunately, no. We actually received this suggestion from one of the reviewers to try to make this a more quantitative result. But the ways in which we thought about how to do this would take too much time, and so we did not prioritize this. But it's a very interesting. It's something that I think it's very relevant to try to do it someday, to have more quantitative measures of how much it improves, or yes. But unfortunately, we do not have any quantitative measurement.
Okay. I didn't remember to read it on the paper, but is it too computationally cost to perform the operation?
No, it's not. And in fact, in a parallel project, we developed a Android application which does this. It does not achieve real-time computation, but it can run on a cell phone without you having to wait a lot of time, like in a few seconds. That depends, of course, on the size of the video, but it's not too computationally expensive.
Okay, because it leads me to my next question. It's related to that. That, for example, when you're predicting the baby heartbeats to simulate it over time, I think it's a very interesting application of the proposal. But I imagine if it's possible to have this measurement over time. Does it? I mean, the idea would be, of course, not substitute the device that makes this measurement, but it could be an extra source of information.
Yeah.
In these scenarios.
Yes, in the way that we did this, I don't think it would be possible to have a continuous measurement, because as you saw, we obtained the frequency from the frequency spectrum of the signal.
Okay.
But I've seen other works which try to estimate the heartbeats from someone, from also the color variations, using. Then they measure the peak of the signal along the time, really along the time, and then they estimate the distance between the two peaks, and from this they estimate the frequency. So it is a possible application, just not in the way that we made this.
Okay. All right. I think we don't have any other questions. So I would thank you again, Thomas, for your presentation and all the authors. And we can continue this conversation over Discord. Let's move on to the next work. The work is Contrastive Analysis for Scatterplot-Based Representations of Dimensionality Reduction, from Wilson Marcílio Jr. e Danilo Eller, and Rogério Garcia from São Paulo State University. You can start the video, please.
In this video, we present contrastive analysis for scatterplot-based representations of dimensionality reduction. Here's our agenda. We use high-dimensional data analysis most of the time when working with data. We often visualize high-dimensional data using scatterplot after dimensionality reduction. For example, if I have high-dimensional data, I can use a DR technique to project it into R2. Using this projection, I can formalize a few questions like, what makes spondylolysis patients so different from normal and hernia patients? To answer these questions, we can use statistical charts to visualize attribute variability and quality metrics that offer a level of interpretability but are not enough to explain cluster differentiation. We can use PCA to find the most important features, but since PCA tends to focus on global information, it makes it difficult to understand the difference among clusters. Or we can use CCPCA, but we are unable to use on thousands of dimensions. So let's define the numerical component of our approach, C expression. Let's focus on F2 and cluster 0. We take the distribution of F2 for cluster 0 and the remaining of the dataset and ask the question, how much these distributions differ? We use t-test to answer this question, which returns t-score and p-value. T-score will measure the difference between the distribution of F2 for cluster 0 and the distribution for the remaining of the dataset, and p-value will tell us how much trustful the result is. We repeat for every feature and for every cluster, and for each cluster, if we order the features based on t-score, we will have on top the most defining features. Here we show all the components of our approach. we have the scatterplot view, the summary view, the scatterplot layout after interaction with the summary view, and the heatmap view to provide an overview of the most defining terms for each component. When users click on a distribution plot, they can visualize the distribution of feature values on the scatter plot, and if more than one distribution plot is clicked, we divide the scatter plot representation into cells to encode all the feature values. For the use case, we use a tweet dataset about COVID-19 symptoms retrieved in São Paulo state, Brazil. We want to understand how the symptoms differ across the state and what are the unique characteristics. So we take the tweets and use the BERT language model to embed the dataset and use the embeddings to project it onto R2. Let's start our analysis on dark allergic cluster. Here, the tweets talk about shortness of breath, anxiety, and chest. Shortness of breath is a severe COVID-19 symptom. We also see anxiety in this cluster, which have grown in the pandemic times. Now let's look at the red cluster. You can see the most defining terms are coryza, stop, risk, mask, worry, and so on, such as fever and pain. Here, tweets are mainly talking about the worrying of wearing or not wearing masks, or worrying about other symptoms that may or may not be COVID-19. Now we have some discussions about the work. The cell-based encoding reduces change blindness because we can visualize various features values on the scatter plot at the same time. R2 offers focus plus context interaction to deal with high-dimensional datasets. And when analyzing different VR techniques, if the clusters are the same, the results will be the same. Then we recommend analyzing at most 5 feature values on the scatterplot representations because of visual scalability. There are more on the paper and the extended video. We recommend you to take a look at them. Thank you.
Okay, thank you, Wilson. Thank all the authors for the good job. Let's see if we have already any question or we don't. So I'll make one. You had hinted on the presentation, but I would like to know from you if did you face any challenge when the data set has a large number of features, a large number of dimensions? What kind of challenges do you see in such database?
Yeah, we analyzed the tweets data set. So we know that when you are dealing with textual data, we have a lot of dimensions, right? Mm-hmm. So for our technique, the most challenge is for the visualization part. For example, in the case of the cell-based encoding on the scatter plot, mm-hmm. Like I said in the video, we try to visualize the feature values using a cell-based encode. So we try to use a color scale for each feature analyzing at the moment, for example. So if a person has to analyze more than 5 features or for example, 10 features, it will be too clouded for the data set depending on the size of the cell. Mm-hmm. Another limitation is how many features we can analyze at the moment. For example, if I have a data set with 2,000 features, I can't analyze this number of features using the technique, for example, by visualizing the distribution plots. But one thing we can use using our technique to decrease this problem is the focus plus context component, in which the analyst can choose what are the features they want to analyze using the focus component. Then the context will follow will update the visualization tool. So to summarize, it's only on the visualization side.
Okay. Yeah, it's just a question of selecting the most relevant features or the features that you're interested into, and then perform the analysis, right?
Yeah. In fact, we order the features based on the differential characteristics for each cluster. So the first one features will be the ones that differentiate the cluster. So the analysts already have that information when they use the tool.
Oh, great. We have a question from Fernando Polovic. Can you use the same idea for clustering, or you need a DR layout?
Yeah, I think you can apply just for clustering without needing the DR layout. We apply it to the DR layout to try to understand the dimensionality reduction. But for example, in the biology community, they use this type of techniques just to analyze the clustering results on high dimension. So they don't visualize, but they use this type of technique to analyze what are the most differentiation features for each cluster. Yeah. So yes.
Speaking about evaluation, do you think have you made an experiment about using the technique to evaluate the DR or the clustering technique? I mean, by analyzing the produced groups in terms of their features to check if it reflects if the DR reflects what's happening on the original dimensions.
Yeah, for example, using the projection of the first slide, which is a data set of patients with problems in the column, we analyze that the technique emphasizes which features can describe the problems of the patients. So in the numerical side, we evaluate our technique against topic techniques, topic extraction techniques, and they provide good results comparable to, for example, LDA and MF. So they are sufficient. Yeah.
Great. Okay, I don't think we have any other questions. We can continue this conversation on Discord. Thank you again, Wilson, and thank all the authors for this work. Okay, let's move on to the last work of this session. Fast and reliable incremental dimensionality reduction for streaming data from Tácito Trindade de Araújo Tiburtino Neves from Federal University of Alagoas, Rafael Messias Martins, Constantine Kusher, and Andreas Karen from Linnaeus University, Danilo Coimbra from Federal University of Bahia, and Fernando Polovic from Dalhousie University. You can start the video, please.
In stream data scenarios, the data needs to be processed as it is received. Examples include network intrusion detection and real-time social media analysis. Among the existing visualization techniques, multidimensional projection, or dimensionality reduction technique, could be effectively used as an analysis tool, allowing the identification and analysis of similarity and neighborhood relationship and patterns. Many techniques present solutions for extreme scenarios, such as online or incremental strategies. However, their use is prevented due to significant constrictions, like the continuous high amount of data to be processed. Extreming combines a change detection approach, an out-of-sample projection technique, and a novel reprojection strategy to update the projection. Extreming is competitive in terms of global distance preservation compared to other streaming and incremental techniques, but it's order of magnitude faster. In a conventional scenario, that is, non-streaming, a multidimensional projection technique performs a mapping of a data set into a set of graphic elements arranged in visual space. Considering a progressive scenario where data is projected as obtained and then discarded, it's not possible to have one function to project all the data. It's necessary a set of functions to project the partitions, so that the union of the partitions projections approximates the projection of all received data. Although the state-of-art of incremental or online projection techniques are based on such approximation, if new structures emerge over time, this can fail to differentiate them from the existing structures. Therefore, for an effective extreme projection strategy, not only the projection function needs to be updated to capture new structures, but also the projection of the previous partitions needs to be adapted to comply with the new projection function. In extreming, the first buffer is used to initialize the process, resulting in the first projection function. To the next buffers, if it does not represent a change in distribution, it will be projected using the current projection function. If a change is detected, the projection function will be updated and the data reprojected is reprojected, followed by the current buffer projection. The steps are repeated while there is incoming data. The change detection strategy is a two-step process. First, some representative samples are recovered from the current buffer by a distance-based clustering algorithm. In the second step, each element in the pre-sample is tested to decide if it will be added or not to the model representative sample. This is done to avoid including instances already represented by the model sample. We use I-love technique to measure how different the instance is from the current sample, using the concept of local densities. If an incoming buffer does not represent a change in distribution, the current projection function is used. On the other hand, every time a change is detected, a new projection function is calculated, and the projection of previous buffers needs to be updated. This step is achieved using a distance-based out-of-sample technique. It's only necessary to compute the distance between the buffer elements and the samples. The problem is that the buffers are not stored, but as we consider that the projection function is precise in terms of distance preservation, the original distance are replaced by the projected distance. We introduced extreming, a novel multidimensional projection technique which shown to be one of the first reliable approaches for projecting streaming data application. The set of comparisons we provide shows that extreme is comparable to existing out-of-sample techniques, while presents a much better trade-off between quality and runtime compared to other online or incremental approaches.
Thank you, Tácito. Thanks all the authors for this very, very interesting work. I think it's very relevant for the kinds of data sets that we have nowadays. Let me see if we have any questions. No, so I'll start with one. Have you experienced situations in which the layout changes significantly over time, and so the projection? I mean, I'm concerned about the user mental maps in such projections. How do you experience those situations?
To avoid this situation, we use procrustes to maintain the mental map
Okay.
to a projection to another.
Because I think it's in this type of scenario, this is a very challenging
Yeah,
problem, right?
without procrustes, we have a lot of rotation or translation in the
Mhm.
points, and the mental map could be affected. But using procrustes, we maintain the general layout over
Okay.
time.
Also, in the Twitter case, I read the paper. The tweets were collected during one day, right?
Right.
The entire data set is comprised of one day tweets. Is that correct?
Yes,
I
12
think
hours if I'm not wrong.
okay. I think it's in the picture, but it's not very visible. Do you have any analysis of how this tense sentence evolved during the day? I mean, in terms of is there an emerging sentiment
No,
or a change in the shape of an existing sentiment? How did you experience this?
no. The evolution over time was not the focus of the study.
Mhm.
We believe that we need more, how can I say, more dedicated visual metaphor to do this type of analysis. So we are looking to show the effectiveness of the technique to compose the final visual metaphor. But we are studying some visual metaphors to do this kind of analysis, temporal
Mhm.
analysis.
Yeah, because I saw you used some kind of fading effect to represent old versus new instance. I think it's very interesting actually, but sometimes it depends on how the instances are structured and positioned on the layout because one can overlap the other, right?
Yeah, the fading can show the oldest instance and the new ones, but the layout are changing.
Uh-huh.
Even that it's a minimal changing, but are changing, and the use of the fading cannot show us this change in the position of the instance over the time.
Okay. We have a question here from Carla Freitas. How do you evaluate the impact of the changes in the data in the projection layout?
Uh, Let me see if I understand how to evaluate the impact of the change in the data in the projection of layout. Again, we try to measure stability, but this kind of measure are better suited in dynamic scenarios, and streaming scenarios are different from dynamic scenarios. In dynamic scenarios, the instance attribute values change over time, but in the streaming scenario, like these tweeters, the instance attribute doesn't change. So we need to think about new metrics to compute this impact of the changes from the data in the projection layout. I think.
Yeah.
And we didn't did this time analysis. Our focus is on the final layout, the final result.
Okay.
But
Okay.
we are investigating this.
Sorry. Say it again, Tasta, please.
We are investigating this temporal behavior.
Okay. Okay, I think our time is up. Okay, thank you, Tasto, again, and thanks
Thank
for
you.
your presentation and for the work. Thank you again, all the authors and all these very good works. I think this was a very interesting and valuable session in SIBGRAPI. And again, I invite everyone here to continue the conversation with the authors on this session Discord. We're finishing now this session. Thank you everyone for staying with us during this session. Please stay tuned for the next SIBGRAPI session. That will be the keynote 3 with Professor Claudio Rosito Jung, entitled Beyond Horizontal Bounding Boxes for Object Detection, starting at 11 o'clock. So this concludes this section. Thank you everyone, and see you.